Welcome back. So in our previous two videos, we've learned to read chemical equations and balance chemical equations. This video will be practicing on balancing equations. And I have three equations that we're going to be working through today. The first one we will do is sulfur plus oxygen yields sulfur trioxide. Hopefully you can see the coefficients there. Here, I'll draw them a little bit bigger since we are now in the lecture hall and we're a little bit farther away from the board. There we go. That should be much easier to see. So first off, we need to write what elements we have. We have two again in this. Just sulfur and oxygen. Next, we need to count how many of each atom we have on each side. On the reactants side, we have 8 sulfur and 2 oxygen. On the product side, 1 sulfur and 3 oxygen. That's a lot of sulfur. But luckily, there's only 1 on this side. So the easiest thing that we can do, the easiest product between 1 and 8 is 8. You can always multiply 1 by the other number to get that number. So let's go ahead and put 8 here. As we put that there, we have to change how many atoms are present on the products side. 8 times the imaginary 1 gives us 8. 8 times the 3 oxygen gives us 24 oxygen. So our sulfurs are balanced, but now we need to balance our oxygen. Can you multiply anything by 2 to get 24? The good news is you can. It's going to be a large number, but you can. If you put a 12 next to that oxygen, 12 times 2 gives us 24 atoms on this side. We have our sulfurs balanced. We have our oxygens balanced. We have balanced this first equation. Let's move on to the second equation. Second equation. We will have Fe2O3, which is rust, reacting with carbon. And that is going to produce just iron. As well as carbon dioxide. So our first step, as always, write out the equation and then figure out what elements we have. We have 3 different elements now. Iron, oxygen, and carbon. Luckily, as we should, we have the same 3 elements on this side as well. Let's put how many atoms we have of each. Only our carbons immediately match up. So we get to work with whatever the easiest is. Let's start with our irons. We have 2 over here and 1 over here. Easiest, 2. Our irons are balanced. Our carbons are balanced. We need to get our oxygens balanced now. 2 and 3. The easiest common multiple among them would be to multiply them together. 3 times 2 is 6. What times 2 equals 6? We would have to put 3. And what times 3 equals 6? 2. So now our oxygens match. But that has also caused a change in our carbons and our irons. We now have 3 carbons and 4 irons. So we need to go back and rematch our carbons and irons. 3 and 1, easiest to multiply it by 3 and get that 3. Between 4 and 2 should be pretty easy. Just multiply what we have by 2 already. 4 times 1 is 4. 2 times 2 is 4. 3 times 2 is 6. 3 times 2 is 6. 3 times 1 is 3. 3 times 1 is 3. Our equation is now balanced again. Let's go on to our final equation. This one is very important because it is the way that plants produce sugar. This is the chemical equation for photosynthesis. Water plus carbon dioxide reacts to make glucose and oxygen. This is the chemical equation for glucose. Plant sugar, food sugar, blood sugar, C6H12O6. 6 carbons, 12 hydrogens, 6 oxygens. It is a pretty large molecule. So, first step, write down all the different elements. So we have hydrogen, we have carbon, and we have oxygen. But we have oxygen twice, which means we only need to write it down one time. And when you're counting oxygens, we'll need to pay attention to both molecules to get our total number of oxygen. Sounds kind of complicated. You just have to keep track of both of them and add them together. So first off, let's put our numbers. So we have 2 hydrogen because of the imaginary 1, 1 carbon, and 3 oxygen because we have 2 here and 1 here. Our total number for this side is 3. Can you see that? Yeah, you can't see that on the video. Okay. Next, we have 12 hydrogen, 8 oxygen, and 6 carbon. Well, let's balance the carbon first. Since it has 1 next to it, it's the easiest one. 1 times 6 is 6. So we throw a 6 down there. We change the carbon to 6. And the oxygen, 6 times 12, or 6 times 2, is 12, plus 1 more, 13. Next, let's look at the hydrogen. 2 times something can equal 12. 2 times 6 can equal 12. We also need to balance this oxygen now. So 6 plus 12 equals 18. So our hydrogens are balanced. Our carbons are balanced. Now we need to balance our oxygens. Since we have 2 different molecules and one of them is on its own, on the side we need to increase. What you need to do is take the higher number and subtract it from the lower number. That gives you 10. We need 10 more oxygens. Can you multiply this by something to get us to that number? 2 times what equals 10? Well, 2 times 5 equals 10. So we need to increase whatever number this is, which is a 1, imaginary 1. We need to increase it by 5 to get us at 10. So 1 plus 5 is 6. So if we put a 6 here, 6 times 2 is 12, plus the 6 here, we have 18. Oxygens match, carbons match, hydrogens match. We are done. Hopefully, this helped explain how to do these balancing equations. And if you have any questions, feel free to show up during one of the Zoom times, and I will answer any questions that you have or to help you through the homework that you have for this. Thank you. And don't die in quarantine.